Okay, you have met me already, and I will actually nicely link to Mike's presentation and talk to you about demand-side flexibility and how we can actually breathe with the grid. So, everyone here, I assume, is familiar with the very ambitious goals of achieving net zero from the UK, but also in many different countries. And what is also clear that wind and solar photovoltaics are key technologies, a key strategic pillar in our energy transition. And we are aiming in the UK specifically to grow renewable energy sources in our electricity mix by 2030 up to 95%. So what does it mean actually to our grids? Let's have a look at this example of a local distribution grid. And what you can see here is the gray area is essentially the demand, all consumers added up. The green area here is essentially generation from wind and solar photovoltaics. And the purple line in the middle is the difference between both of them. And what we can see, what is interesting here to see, that there are sometimes over the course of this 1 week, where we have more demand than we are actually able to generate. But there are also times where we are actually generating more of renewable clean energy that we are actually able to consume. And this obviously poses new questions to our grids, to our energy supply systems, and also to us as consumers of this energy. So what we observe is that our generation is decentralizing more and more. We observe more volatility in the generation because we have those intermittent renewables in our grids, which are driven by weather. And there are more and more questions around resilience. So when we don't have the balance between supply and demand. In distribution grid, we monitor and measure it by voltage. In transmission grids, we use frequency as a metric to monitor the resilience of our grids. But essentially, this is where we need to act and to do something. And our ambition is clear. We want to have more renewables. So my question here to you is, what if the key to more renewables is not only generating more, but actually consuming smarter? Let's pause here. I would like you to take on a small journey to places which I really like here. And now just please follow my instructions. Please close your eyes for a moment. And now take a deep breath in. Hold your breath for 3 seconds. 3, 2, 1. And now slowly breathe out. And now open your eyes. So the air is existential to us as humans, as energy is to our economic systems. Both are non-negotiable, but you have just adjusted your breathing to my command, to an external signal. So my question is, can we do the same with our energy demand, with our energy consumption? And this is where we talk about the topic of demand-side flexibility. So what you can see here on the left-hand side of the slide is a typical daily profile of solar panel. Generation is not existent during the night, but then slowly picking up and peaking around the lunchtime, and then slowly dropping down towards the evening. And on the bottom, we see a demand profile, in this case of a factory of the same day, and we see it's quite flat. But when we talk about demand-side flexibility, what we aim here is to essentially reduce our demand when we have not sufficient generation from renewables, and increase it a little bit when we have access of renewables available to us. So when we speak about demand-side management, we essentially talk about targeted interventions into our loads, into our load profiles, based on external signals. And the goal can be to increase utilization of renewable energies in the grid, but also to optimize the system as such, and systems operations, and also to optimize and contribute to system resilience. So now you would ask me, hey Diana, how can we actually do it? We heard from Mike already some examples of private households, and this is where I would also like to start with giving you some examples. So for instance, I have been working with City of Amersfoort, where we looked in different types of residential areas, and we essentially looked into the houses, into the apartments of people, and identified different measures, different equipment which we can use to make our demand more flexible. And the examples Mike already gave are the heat pumps. With a water storage, with a thermal storage, we essentially can decouple the supply, the generation of thermal energy, and from the actual point of when we consume it. These are obviously our electric vehicles and home batteries, which are essentially storing the electricity. But this can be also smart appliances, so such as dishwashers, washing machines, ovens, and so on, because they are not operating all the time. So you will ask me, but does it matter? They're so small. Yes, you're right. But across all of us in this room, across the entire city, across the entire country, actually it adds up and becomes quite a lot. But of course, we can continue walking outside of this building, look around, and find many other examples in our urban settings, but also in our rural settings, where we can use district heating and cooling systems. We can use water supply and wastewater treatment systems where we have a lot of pumps, we have a lot of water storage, so we essentially can adjust when we pump the water to essentially store the electricity when we have the access to it in form of water. Of course, our public charging networks and our public real estate, like here in this building, where we will have similar opportunities to flexibilization as we would have in private households. And of course, last but not least, there's one more sector to talk about. And I have been working very extensively with different manufacturing companies in order to understand how we can actually make industrial energy demand more flexible. And based on my work with different manufacturing sectors, so from pharmaceutical, automotive, polymer processing, metal processing, I have been able to identify actually 4 different archetypes of measures, how we can make factories more flexible. And this essentially reach from converting electricity and storing it in other energy forms, such as thermal energy for cooling, for heating, compressed air, steam. All of it is energy, just converted to a different form. This is, of course, about thinking how we actually schedule our processes and where is the opportunity to schedule the processes based on the grid demand. This is also about the capability of switch between different fuels. I don't know whether you know here, but in most factories, to really ensure that we always supply our processes, we always have redundant systems. So if we need 1 unit of thermal energy, we will have 2 units installed there. So my question to you is, does it need to be always based on the same fuel? Or can we use different fuels, different systems to supply the same energy type which we need for actual process? And yes, this is possible. So we can have electric boiler and gas boiler installed in parallel. And actually manufacturers do like it because it also provides diversification and more resilience to their factories, to their production. And last but not least, of course, electrification of our vehicles. And this is, of course, not only the typical private like cars, but actually also all the different types of vehicles used in manufacturing settings. So to sum up, for the UK, through electrification, we do know that our electricity demand will grow from today till 2050. And when we look at the so-called consumer-led flexibility, so adding up all the potential which I have just presented to you, we are currently using about 4% of the peak electricity demand. But actually by 2050, we will have way more potential to use and leverage here. Which leads me to conclude that demand-side flexibility is a tool which is available to us, Most of technology is already there. Most of the solutions are already there. However, there's still scope for a lot of research, because what we need to understand are the different interactions between different sectors and how they influence each other. We need to think about how we can coordinate all these users with the system, so digitalization, AI, and so on, to link to what Mike has been just presenting. But there's also a lot of questions related to social aspects, how people react, what are the market designs, what are the governance, the right governance for this type of markets. And finally, what is important here, no one can do this alone. So we do need a central function which will help us to coordinate the potential. Thank you.